Okay, so these are the solutions to the related rates problems on our worksheet. Starting with number 1, let's see, we have a cone and the radius is 30 centimeters and the height is 10 centimeters. We are told that the water level rises as water is being poured in at a rate of 4 centimeters per second. And we are asked for the rate at which water is being poured into the cup. And that is when the water level is 8 centimeters. So the relationship between volume and height of the cone is going to be 1/3 pi r squared h. But notice we're not getting into the rate of the radius changing. And they do give us this relationship here where the height is 10 and the radius is 30. So that means that the height is 1/3 of the radius, or that the radius is 3 times the height. So I'm going to rewrite this and just have 3h squared there, which means our volume is 3 pi h cubed. Now when we take the derivative, we don't have to worry about that radius. 3 pi, 3h squared, dh dt, 3 pi times 3, h is 8 squared, dh dt is 4. And we get, that should be 2304 pi, and the volume is given in centimeters cubed per second. Question 2 is another conical paper cup. Oh boy, and it's different now because water is pouring out of it. Okay, so it's 10 centimeters tall, and radius is now 20 centimeters. All right, so the bottom of the cup is punctured so that the water level goes down. So the height is decreasing at a rate of 2 centimeters per second. At what rate is the volume of the water changing when the water level is 2 centimeters? So we're going to do the same thing as 1. This is 1/3 pi r squared h. Again, we're not getting into the rate of change of the radius. And we're told that the height is half of the radius, or that the radius is twice the height. So I'm going to make that substitution. I've got 1/3 pi. The radius is 2h squared. All right, so that's 4/3 pi h cubed. Then our derivative is going to be 4/3 pi 3h squared dh dt. So let's see, these 3's cancel. So we've got 4 pi, 2 squared, -2. So negative 32 pi centimeters cubed per second. Number 3, we've got a crowd gathering around a movie star, forming a perfect circle. The radius of the crowd increases at a rate of 3 feet per second. Okay. And how fast is the area taken up by the crowd increasing when the radius is 13 feet? Alrighty, so the area of our circle is pi r squared. And then that derivative is dA dt pi 2r dr dt. So we've got 2 pi here. R, they tell us, is 13, and dr dt is 3. So what do we have? That looks like 78 pi. And then the units are going to be in feet squared per second. Okay, number 4, we've got a perfect cube, ice cube, melts so that the lengths of its sides are decreasing at a rate of 3 millimeters per second. So I'm going to call a side S. So that ds dt is negative 3 millimeters per second. Okay, the very cool thing about this cube is that as it melts, it retains the shape of a perfect cube. And we need to know at what rate the volume of the ice cube is changing when the sides are 6 millimeters each. All right, so our volume of a cube is side cubed. So when we take the derivative, we get 3s squared ds dt. 3, 6 squared, and then negative 3. So let's see, that is 36 times negative 9, I think, negative 3, 24, I don't know, that's what we're going with. So negative 324, the volume is being measured in millimeters cubed per second. Question 5, we have another cube, and that cube is growing so that the length of its sides are increasing at a rate of 4 over s meters per minute. Okay. How fast is the volume of the cube decreasing or increasing when the sides are each 7 meters? All right, so this means that ds dt is going to be 4/7 meters per minute. Okay, so the volume of the cube is side cubed. So dv dt is 3s squared ds dt. And we're looking for dv dt, so we've got 3 times 7 squared times 4 over 7. All right, one of these s7s will cancel with one of those, and we just have 3 times 7 times 4, so 21 times 4 is 84 meters cubed per minute. 6, we've got another perfect cube. Okay, ice cube is melting, so the length of the sides are decreasing at a rate of negative 2 over s millimeters per second. Okay. Assume that the block retains its cube shape as it melts. At what rate is the volume of the cube changing when the sides are 7 millimeters each? So that means that this is negative 2 over 7 millimeters per second. Okay, so the volume is s cubed. dv dt is 3s squared ds dt. So we get 3. 7 squared, negative 2 over 7. This cancels out with one of those. So now we have 3 times 7 times negative 2, and we get negative 21 times 2, which is negative 42, which makes sense because if the sides are decreasing, then the volume would be decreasing, and that's going to be cubic millimeters per second. Okay, this problem involves the area of a square, but based on the diagonals that we are calling, they're calling x. So it's helpful to know the formula for the area of a square in terms of its diagonal, which is something that we don't often use. And if we call these the sides, we know that we've got side squared plus side squared is d squared. So 2 side squared is d squared, which means that side squared is half of d squared. So if the area of a square is side squared, then it's also 1/2 d squared. So it's good to kind of just walk around knowing that this is how you find the area of a square using the diagonal. But I promise I won't spring any formulas on you that you wouldn't know already. All right, but in this one, we're going to use x squared. I suppose it's confusing if we took the derivative and used d. So we've got 1/2 2x dx dt. These cancel. We've got x here. Let's see, erase this. So x, they tell us, is equal to 12 meters. And then dx dt, they say, is -3 over x, so it's -3 over 12. Those 12 cancel, the 12s cancel, and we get -3. And our units are going to be square meters per minute. Number 8. A spherical balloon is deflated, so its radius decreases at a rate of -2 over r centimeters per second. At what rate is the volume of the balloon changing when the radius is 3 centimeters? Okay, so that means that this is -2/3 centimeters per second. So the volume of a sphere is 4/3 pi r cubed. So we've got 4/3 pi times 3r squared times dr dt. Now we just substitute. Those 3's cancel. We've got 4 pi, r is 3, dr dt is -2/3. One of these cancels out with one of those. I get -24 pi cubic centimeters per second.